Firstly, look at the question. The table shows the sales, price, and the space. Sales is the Y, price and space X1 and X2. We want to know if the price X1, space X2 will impact on sales. And what's the relationship among them? We want to find a predictor. Yes, we want to use the price and space to predict sales. That's the question. Okay, so here, if you meet a question like this, if you want to use the multiple regression, linear regression, firstly, you need to draw the plot. Okay, you need to draw the plot to check if they have linear relationship. So that's very important. That's the first here, plot, price, space, and sales scatter plot. Okay, and everyone show this result. It's correct. We will use the matrix scatter. Okay, and through the result here, it shows that the sales and the price, the sales and space, the space and price. You can see they all have the linear relationship. Okay, yeah, and Jisoo said that the homoscedasticity also exists. That's correct. That's good. Great. Okay, so here's the analysis and the conclusion, and it shows the homoscedasticity exists. Okay, that's the first part. The second part is then, yeah, through this plot, through these graphs, you can see that they have the linear relationship. Then next, you need to test if the linear relationship can be accepted or has significant linear relationship. Significant. If we use the significant, then you need to test, right? Okay, so next step 2. What you need to do is you need to calculate the Pearson correlation coefficient. Okay, then here's number 2. The question 2. Okay, then analyze here the correlate bivariate correlation, sales, price, space. Okay, and the correlation coefficients is Pearson, right? Okay. Okay, then you can see that all of the correlation, the Pearson correlation is significant, since all the significance is less than 0.001. Okay, and Jisoo's analysis and conclusion are correct, quite good. Okay, because the sales and the price, the coefficient, the correlation is 0.922. Sales and space 0.849. Price and space 0.929. 0. All the significance is less than 0.001. Hence, the correlation of 3 variables are very significant. Okay, that's the step 2. With this conclusion, since the price and the sales significant, the space and the sales, the coefficient is significant, right? The correlation is significant. Then next, it means we can use linear regression. If the price and sales, the correlation is not significant, then price will not be used as a variable to predict sales. Okay? Yeah, but this time, price, space, and sales, the correlation are all very significant. In this case, price and space will be used to predict sales. Then we start number 3. Number 3 is this one. Okay, so next we can use the linear regression. What contribution do both shelf space and price make to the prediction of sales of t-shirts? Okay, let's look at here. Analyze here, regression. And this time we will use the linear. Why? Because x1, x2, and y, the relationship is linear relationship. So we will use the linear. We want to use to establish a linear model. Yes, please select linear here. Dependent. Dependent variable is y. Y is sales. Independent variable is x. x1, x2, this time price, space. Okay. Since now we will use the default method, enter. Enter method means price and space both enter the model. Yeah, click OK here. Okay, let's look at here. Here we have the model summary, ANOVA, coefficient. Yeah, I want to paste them. Oh. Okay. One, two, three. Okay. Paste them here. Okay. Here is the model summary. R square, adjusted R square. Explain this part. Okay. Here, R is 0.922. R square is 0.850. adjusted R square is 0.825. Okay, here if the R equal to 1, then the model can thoroughly explain 100%. So that means the accuracy of the model, the accuracy of model is 100%. Okay, if R is so that means if the R is 0, that means x1, x2 has no impact on y. Okay, so if R is 1, so that means the accuracy of model is 100%. It's the highest. Okay, now this time the R square is 0.825, so that means hence the R square is close to 1. The accuracy is high. Okay, so here is the first through the model. Okay, through the model you can analyze like this. Okay, yeah, I think I'd better to separate them. Okay, next is the ANOVA. Okay, let's look at the ANOVA here. The ANOVA is to test if the model is significant. It means if we can establish a model. So through here, so here is the model test. So from the results of ANOVA, look at here, it's regression, right? The model is regression. The regression, the F value is 34.081. The significance is less than, look here, it's the significance. The significance is less than 0.001. Okay, here the hypothesis is the model is not exist. Okay, but here the significance is less than 0.001, so that means the model is exist. Okay, at least one of the coefficient of the variable is not equal to 0. So the model is exist. Here from the result of animal, f value is 34. The corresponding significance is less than 0.001. So that means hence the model, the regression model, right? Regression model is significant. Okay, here is the analysis and conclusion of this test. Next, we will test if all the coefficients are significant, because here it shows that at least one of the coefficients of the variable is not equal to 0. Okay, and next we want to test if all the coefficients of the model, coefficients of the variables are significant. So let's look at the number 3. This is the coefficients, right? The dependent variable is sales. Here's okay. Let's look at the coefficients here. Yeah, through here, it has in the model, the constant, the variable is price, space, dependent variable, it's just like y, right? Price like x1, space like x2. Okay, and here you can see that the constant, we will skip it. We will not test the constant. First, let's look at the price, this variable. For this variable, look at here. The unstandardized coefficient is 10.5. Yeah, let's look at the t. Here is the significant test. Okay, the t value of the price is 3.219. The significance is 0.007, which is less than 0.05. So that means the coefficient of price is not equal to 0. So it means the coefficient of price is significant. Next, space. The t-value is 0.022 and the significance is 0.983. 0.983 is very close to 1, right? So it's more than 0.05. It means space, the coefficient of space is not significant. It also means space has no significant impact on sales. Okay, so here our answer is the t-value of price is 3.219. The significance is 0.007, which is less than 0.05. Hence, price of price is significant. Okay, it also means that means the price has significant positive impact on sales. Okay, here is an analysis and the conclusion. Okay, similarly, I copy it. Okay, and then the t-value of next is space. The t-value of space is 0.022, and the significance is 0.983, which is more than 0.05. Hence, the coefficient of space is not significant. If it's not significant, it means the coefficient of space is equal to 0. Okay, the conclusion is the space has no significant impact on sales. Okay, understand? Got it. Okay, here is this for this. Does shelf space impact on sales significantly? No. Does price impact on sales significantly? Yes. Okay, so this first question we answered. The shelf space has no significant impact on sales, while price has significant impact on sales. Okay, then since the price significant, the shelf space is not significant, right? So yes, we needed to establish a new predictor, a new model. Okay. Okay. Also here, through this table, we can establish a regression model. I write the model here. Okay, if we can see that the coefficients, the constant is 2.029. The coefficient of price is 10.5, and the space is 0.057, right? Okay, so the predictor Y, or you can say sales, equal to 2.029 at 10.5 multiply price at 0.057 multiply space. Okay, here is the regression. Yeah, the regression model is the cells equal to 2.029 at 10.5 multiply price at 0.057 multiply space. So if you have the price, have the space, the data of price, the data of space, then you can use this regression model to predict sales. Okay, understand? Everyone understand? Okay, but this time the space is not significant. Space is not significant, so that means the predictor is not perfect. We need to build a new predictor. All the coefficients of the variables are significant. So next, I'll demo. Next, analyze here, regression, linear, okay, and here we will change the method. Here we will use the stepwise method. Oh. Yeah, I want to use the stepwise. Yeah, okay, here stepwise. Okay, here use stepwise and okay. Yeah. Also here one by one. Yeah. When we use stepwise, still the R R is 0.922. It's not decrease. Why? Because okay, so next use stepwise method to establish a new model. Okay, here still the R is 0.92. The R square is 0.850 and adjusted R square is 839. Okay, so you can see the adjusted R square is increased, right? Okay, hence the R square is close to 1. The accuracy is high. Yeah, here is the okay, and then next is ANOVA. Okay, also I copy it, right? We can copy it here. Okay, The F value is 73.840. Okay, and the significance here, the significance is less than 0.001. Hence, the regression model is significant. That's the number 2. And number 3, yeah. When we use the stepwise, look here, the space here is not significant. The space, look here, space is excluded, right? And now in the model, we just has a price in the model. Okay, so here, we can write that the t-value of the, so that means the space the t-value of price is 8.593. Okay, this is the t-value. The significance is less than 0.01. It's less than 0.001. Hence, the coefficient of price is very significant, right? Yeah, the price has significant positive impact on sales. And the space, look here, the space is excluded. In the model. Okay, everyone, use this result. Please write the new predictor. What's the sales? Okay, please write the new predictor according to this result.